So not everybody can handle taking Lipitor, and there are some side effects that some people feel more than others. But you know, it's definitely been proven that high levels of LDL do cause people to have a buildup of plaque in their arteries. So if you can't take the drugs and diet and exercise doesn't work, there's another way to get the LDLs out of your blood, and that's filtering it out. And this is a picture from the local paper, just taken in April. Now in the Austin area where I live, at one of the hospitals, you can have your blood filtered. And through this filtering mechanism, it removes the LDLs, okay, because, and this is just based on density, the blood, it's like a dialysis machine where somebody sits there for about 4 hours and your blood is literally filtered out of your body. I see all the blood here going through here, filtered out of your body, and then the low density, you know, the blood is allowed to separate. And if you've ever seen blood that has been drawn that's just sat there for just a few minutes, you'll see that the fats kind of rise to the top. You can just tell it's this yellow looking liquid, and you can just see, I mean, in a tube of blood, sometimes it'll be, you know, the person's blood will be all red and pretty healthy looking up to here, and then maybe just a little bit of what is clearly like an oily substance on top. And some people, you'll see their blood and then there'll be an oily substance, like this much of it's the oily substance. You can just see very clearly that some people have more fat in their blood than others. Anyway, there's this new device where you can sit there and have your blood filtered to remove the LDL. And so there was an article about a woman who's having that done now. She used to drive to San Antonio to have it done, and now she has it done in Austin, and apparently your insurance pays for it. So that's how bad it is to have too much, you know, bad cholesterol in your body. Now, because of all of this awareness that saturated fats are not good for you, then the food industry has, you know, gotten a hold of that and tried to create low-fat foods. Because if it's shown that fat is bad for you, then there was this whole thing, especially in the late 80s, early 90s, of low-fat foods. And so, for example, low fat means foods that are labeled as low fat or fat free. For example, if it's low fat, that means you take some of the fat out. For example, 1% milk versus whole milk. That milk is considered low fat because some of the fat has been removed. Fat free is when you take out all the fat. Sometimes they add back a fat substitute. Now, in the case of milk, like skim milk, it's just fat free. They've taken the milk out, or you can have fat free yogurt. But some foods, they add a food substitute. And I just threw down some names of some food substitute or fat substitutes here. For example, cellulose, we'll talk about that when we talk about carbohydrates. That's a carbohydrate that your body cannot metabolize, but it gives the texture of fats. Fiber, you can't digest most fibers. And then all these other starch-based, it's mostly modified food starch that's been modified so your body cannot extract the calories because the enzymes no longer recognize it. Protein-based, it's just like, for example, modified whey protein concentrate. It gives the same feeling and texture as fat. And then different emulsifiers, and then this one, Olestra, I'll talk about that for a minute. Olestra is a fat substitute that came on about 10 years ago. And what it is a sucrose polyester. So instead of having fatty acids chemically combined with glycerol, fatty acids have been chemically combined with sucrose, and sucrose is like table sugar. And so you have this big sucrose molecule, which we'll look at them later. It's kind of like this. And then instead of having hydroxyl groups, you have all these fatty acids stuck to the sugar. Now, because the fatty acids, the way they are bound to the sugar, the body doesn't have any enzymes to recognize this ester linkage here. So it just cannot fit into a normal enzyme. So this type of fat, it kind of tastes like fat and it has the feel of fat because of all these fatty acids, but it's not digestible because there's no enzymes. So the body, it just passes right through the body. So there's been all kinds of food science that has been done to try to make fat substitutes with varying success. And then cholesterol-free foods, those are cholesterol is found in animal fats. So, and one of the things cholesterol does in animal fats is it makes the fat more stiff, And so, for example, that sometimes is good when you're making something to have a stiff fat, for example, if you're making frosting or something like that. And so an alternative to using fats that were stiff that also contain cholesterol was to hydrogenate vegetable oils that did not contain cholesterol to get the same consistency but no cholesterol. Now that was all the craze, like 40, 50 years ago. This process of hydrogenation, where you take a fatty acid, which is typically a part of a triglyceride, and you an unsaturated fatty acid, and you hydrogenate it, which means you chemically combine by an addition reaction hydrogen. And when you by an addition reaction, then you just add the hydrogen, and one of the double bonds is removed because the hydrogens, are added to that double bond. So the carbons that were unsaturated are now saturated. Okay, and so if you have saturated fatty acids, you increase the melting point, and so what was oil then becomes a solid. For example, butter has cholesterol and saturated fat, and so that's been linked, to health problems. So what did was they took vegetable oil and added hydrogen to it to make margarine. So margarine was considered a great butter substitute. The problem was that they later found out was that hydrogenated fats are actually worse for you than the original saturated fats in the natural source. So what they thought was a better thing, so you could use margarine instead of butter, reduce your cholesterol, actually these hydrogenated fats are actually worse. And the reason why they are worse is because when you have a polyunsaturated fatty acid, such as this here linoleic acid, and you hydrogenate it, sometimes the hydrogenation occurs and you end up with what's called a cis conformation and sometimes a trans. And as it turns out, this is called a cis. When you have a double bond and both of the hydrogens are on the same side, we call that a cis isomer, because it's got the same chemical formula, but structurally it's slightly different, so it's a structural isomer. And if the hydrogens end up on the opposite sides and the rest of the molecule is on opposite sides, then that's called trans. So there's two different ways when you hydrogenate a fat that your double bonds can end up. Okay, so if you completely hydrogenate and you completely saturate, you don't have to worry about this because you've removed all of your double bonds, and it's just like any other hydrogenated fatty acid that would be found in nature. But what happens is when you have a polyunsaturated, you can have some flipping around. Normally in nature, the double bonds are in the cis conformation. So right here you'd have a hydrogen, and this would be R on the same side of the bond. That's the way it normally is. But if you have a polyunsaturated fat and you hydrogenate it, you can end up inadvertently making a trans fatty acid, in which case the double bond has flipped and you have a, let's see, the one hydrogen down here and one hydrogen down here, and then this would be your R group down here and your R group down here. So they're trans, they're on opposite sides of the bond. Here they're on the same side, here they're on opposite sides. As it turns out, this the way this double bond is in the cis conformation puts a kink in the bond, and so the fatty acids can't get as close together, and so that's good. Then we would have what we would consider oils because they can't pack as close together. But in the trans case, they can pack closer together, and even though there's a double bond here, they're still going to act like a saturated fat and pack closer together and lower the melting point. And the problem with this is, for some reason, and it's not, people aren't quite sure, but a diet that has these trans fatty acids is worse than a diet that just has the original saturated fatty acids and cholesterol. For some reason, the trans fatty acids increase the LDL levels more than any other dietary change. So what they thought was better by making, for example, margarine out of vegetable oils to give the kind of consistency that people want in butters, because you can spread margarine like you can spread butter, actually is worse for the diet. And so there's all kinds of food science going on where the food people will use hydrogenated vegetable oil to make, for example, processed foods. To get the right consistency and texture, for example, Little Debbie snack or something like that, cookie with the white stuff on the middle, would be made with, instead of using lard, which is spoils faster and has cholesterol and everything else, they'd use these hydrogenated vegetable oils, thinking that they're giving something that's going to have longer shelf life and everything else, but really it's actually worse for you. And they're still not quite sure. I had heard at one point it was because your body doesn't have an enzyme to recognize a trans double bond. It only can recognize a cis double bond, and they build up. The double bonds are still there, so they're susceptible to oxidation, which then could lead to the formation of free radicals, which then could lead to the formation, or could lead to cancer. There's all kinds of reasons why people think that it's a problem. They're not quite sure yet. All they know is that it is a problem. And as a matter of fact, there's legislation right now, because the legislature in Texas is in session right now. Somebody from the Dallas area has introduced a bill to remove all trans fatty acids from school lunches or school vending machines. Okay, because there's so much evidence saying that trans fatty acids are bad for you. And over the last 5 years, you'll notice that a lot of snack foods, they now say contains no trans fatty acids, contains no hydrogenated fats, but you have to be really careful because even the guideline of the FDA is if it's less than 0.5%, they can say no, and there really might be some still in there. So you have to be real careful with processed foods. Okay, so the trans fatty acids in it are acting more like saturated fats and seem to increase bad cholesterol in the blood. That's the moral of the story. So here's the way oleic acid, a natural fatty acid, looks with the cis conformation, and here's elaidic acid, a trans fatty acid that would be the result of a hydrogenation of a vegetable oil. Okay, these are not found in nature. Trans fatty acids are not found in nature. They are a product of food processing, and they're very bad for you. So in this lecture, we've looked at different what are lipids. We've looked at the definition of lipids. We've looked at some essential fatty acids. Some fatty acids you have to have in your diet. Some fat is necessary in your diet. And then we've looked at the fact that too much saturated fats or hydrogenated or partially hydrogenated fats are bad for you. And we've looked at the fact that it's because the way the fat moves around your body in the lipoproteins depends on if it's carrying it to or from the liver. And those low-density lipoproteins are what we consider the bad cholesterol, because that's carrying the cholesterol back out into the body, and it can get hung up all over the place. All right, so that's basically it. We'll look again at fats when we talk about the fat-soluble vitamins and the calorie counting.